Hello, welcome to the last in our series of videos where we solve the questions in the WASSCE 2019 May-June Elective Math Paper 1. We've already solved questions 1 to 30 in previous videos, and in this video, we'll solve questions 31 to 40. Question 31 says, the function f such that x goes to x squared plus px plus q has a turning point when x is minus 3 and a remainder of minus 6 when divided by x plus 2. Find the value of q. Well, we've been told that there's a turning point when x is minus 3. Now we know that this is the this is a quadratic function, and so its graph, because the coefficient of x squared is positive, its graph is going to look like this. Okay, this is not looking too pretty, but the point is you're going to have this, and it's going to be such that this turning point, or the minimum, is going to occur when x is minus b over 2a. This is a fact about parabolas. It's also a fact about quadratic functions because their curves are parabolas, and we can derive it a number of ways. The first is that we can take the derivative of a function of this sort, ax squared plus bx plus c, but we can also use a quadratic formula where we have x equals minus b plus or minus square root of b squared minus 4ac all over 2a. What this tells us is that x has two solutions. One of them has plus, and then one of them has minus. If you add those two solutions together, you're going to find that you will get minus b over a. And to find the average of the two solutions, you get minus b over 2a. So that's how we get this. And so we know that in this case, in this question, our a is equal to 1 and our b is p. So our x is going to be minus p over 2a, which is just 2. And we are told that this is equal to minus 3. This means that p is equal to 6 using this fact. Like I said, we can also differentiate. So let's just convince ourselves that we get the same answer when we differentiate. So when we differentiate this, what do we get? We get 2x plus p, and we are told that a turning point occurs when x equals minus 3. Now at the turning point, this derivative must be equal to 0. And when that happens, what is p? P is equal to minus 2x. But we've been told that x is minus 3. So this is equal to minus 2 times minus 3, which is 6. So we found that p is equal to 6 in two different ways. And that should give us a lot of assurance that we are doing the right thing. So having found p, how do we find q? Well, let's first substitute the value of p into the equation to see what we get. We get x squared plus 6x plus q. So that's the current state of our function. And we've been told that it leaves a remainder of minus 6. Let me remove this line. It leaves a remainder of minus 6 when divided by x plus 2. So here we can use the remainder theorem. By the remainder theorem, if this is our f, if this is f, such that x goes here, then, or let me write it better. Let me say f of x. So if f of x is such that x squared plus 6x, or f of x equals that, then we know that by the remainder theorem, f of minus 2 should give the remainder. So this is the factor, so we set it equal to 0 and we get x equals minus 2. So if we put minus 2 for x in f, the remainder or the result should be minus 6. So let's do that. We put minus 2 here. Minus 2 squared is 4. If we put minus 2 here, we get 6 times minus 2, minus 12 plus q equals minus 6. What does this give us? This gives us that q must be equal to 2. So we found our q, and I've overwritten some of the options we were given, but 2 is one of the options. So that should be our answer. But let's just see if we can confirm that indeed this is our answer. So let's see if we can use another method to check that q is 2, or if we can otherwise convince ourselves that our answer is correct. So let's we know now that we found q to be 2, our f of x is equal to x squared plus 6x plus 2. All right, let's find the turning point by differentiating, and then let's also see if when we divide by x plus 2, or when we use the remainder theorem with x equals minus 2, we're going to get the result. Those two tests, if you do them, you're going to find that indeed the numbers we get are correct. Therefore, we should be satisfied with our answer. All right, I know we may have used a bit of a convoluted method in solving this problem, but the important thing is to be able to solve it. So whatever method works for you is fine. The next question is to find the derivative of this function, y equals that. We're supposed to find dy dx. Now here we have to use the chain rule because we have something like a function of a function. If we write 5 minus x as u, then we have this where u equals 5 minus x. So we have a function of a function, and by the chain rule we first have to we can use, if you like, 5 minus x. We can differentiate normally, but then we also have to differentiate what is inside the brackets. And when we differentiate this, what do we get? 5 minus x, the derivative of that is minus 1. So this whole thing times minus 1. And when we multiply by minus 1, what do we get? We get 3 times 5 minus x all to the power minus 4. And that is the same as 3 over 5 minus x to the power 4. So that gives us A. All right. The next is question 33. Which of the following vectors is perpendicular to minus 1, 3? If two vectors are perpendicular, then their dot product is 0. So we are looking for the vector which, when dotted with this, gives us 0. In fact, one rule or one trick you might remember is that when you have a vector xy, one way of finding a perpendicular vector is just to write minus or y minus x. That's one way to find it. So if you have this at the back of your mind, you know that somehow we must flip 3 and minus 1, and we must negate something. If we find the dot product, let's just confirm. So if we find the dot product here, what do we get? We get x times y, which is xy, and then plus y times minus x, but y times minus x is also xy. So this is indeed 0. So that's the idea we want to use. That first we want to be flipping 3 and minus 1 somehow. So this is out, this is out, and we are dealing with this and this. Now remember that we are not just flipping, but we are also flipping and negating. So B looks attractive. Let's dot 3 1 with minus 1 3 and see what we get. We have 3 times minus 1, which is minus 3, plus 1 times 3, which is 3. So this is 0. That tells us that this is our answer. But let's just confirm that this one, which was looking promising, doesn't work. So minus 3 1 dot minus 1 3. What does it give us? We have minus 3 times minus 1, which is 3, plus 1 times 3 is 3, which is 6. This is not 0. So let me just write, this is not equal to 0. So this is out. And our answer is B. The next problem is 34. Find, correct to the nearest degree, the angle between P equals that and Q equals that. Now these numbers are really interesting. They should ring a bell because they result from very famous triangles. There is the 3 4 5 triangle. 3 4. When you have a triangle, a right angle triangle whose legs are 3 and 4, the hypotenuse is 5. And when you have another such triangle, right angle triangle whose legs are 12 and 5, the hypotenuse is 13. That's why I'm saying that these vectors should ring a bell. The reason we need this is that we need to find the magnitude of these two vectors, because we know that when you have two vectors, P and Q, you can find the dot product. So let's say you write this P dot Q. When you write this, it is equal to the magnitude of P times the magnitude of Q times the cosine of the angle between the two of them. So if the angle between them is theta, then you have this expression. The dot product is the magnitude of P times the magnitude of Q times the cosine of the angle between them. And so we need the magnitude of P, which we've already said. Sorry, this is the magnitude of P, 13. The magnitude of Q is 5. So we need to find the dot product. Let's write the dot product. The dot product of P and Q, we have 12 minus 5, and then we have 4 3, and then we've already found the magnitude of P to be 13, and we found the magnitude of Q to be 5 cosine of theta. So if we can somehow find this dot product, we equate it to this, and then we're good to go. So let's do that. 12 times 4 is 48, minus 5 times 3 minus 15, and this is equal to 13 times 5 is 65 cosine of theta. 48 minus 15, that's 33, equals 65 cosine of theta. That means that the cosine of the angle between them is 33 over 65. So we need to find the angle whose cosine is 33 over 65. And when you punch it into your calculator, you're going to find that it's 59.48 something degrees. So this is our answer. Now, I said that these numbers should ring a bell. If they didn't ring a bell, you don't have to give up. You can still find the magnitude. The magnitude of a vector when you're given the components is just the square of the x component. So if you have a vector like this, x, y, its magnitude is just the square root of the x component squared plus the y component squared. So in the case of 12 minus 5, the magnitude is just 12 squared plus minus 5 squared, and this is equal to 12 squared is 144 minus 5 squared is 25, so we have that, and this is equal to the square root of 144 plus 25 is 169, and the square root of 169 is 13. So that's the same thing we got here, but you can avoid this long calculation by memorizing these two triangles. They are they occur so frequently that you just have to know them. The next is question 35. It says find the area between the line y equals x plus 1 and the x-axis from x equals minus 2 to 0. We can try to sketch this line. If you remember our rules of curve sketching, one thing we do know is that the line y equals x, the line y equals x is the line that passes through the origin, and it's basically 45 degrees to the x-axis, and all this is doing is it's adding 1, so it's shifting it upwards by 1. So we know that this is 1 and this is also 1. So if you're able to see that, then this problem is easy. But if you don't see that, there are many other ways you can plot this graph. You can pick x equals 0. So you can ask yourself, what happens to y when x is 0? When x is 0, y is 1. So that tells you that the point 0, 1 is on the curve, is on the line. So that's 1 point. And then you can also ask yourself, what happens to so we first picked what happens when x is 0. So we can now pick what happens when y is 0. So when y is 0, what happens to x? Let's make y 0. So we have 0 equals x plus 1, and x must be minus 1. So in that case we have yes, minus 1. So this is it. This is the curve. So you know that the point minus 1, 0 is also on the line, and with those 2 points, knowing that this is the equation of a straight line, you can immediately draw this. Now when you draw this, he's asking us to find the area between this line and the x-axis from minus 2, x equals minus 2 to x equals 0. Now this is x equals 0, this is x equals minus 1, x equals minus 2 is going to be here. So minus 2, and we are now supposed to find this area, which is this plus this. That's the area in question. Now we can use symmetry if you're able to see that this area, this imaginary area, which I'm going to shade with green, this imaginary area is equal to this purple area down here, then you know that the area we are looking for is equivalent to this area plus this area, and this is a rectangle with sides 1, 1, so it's even a square. That means that its area is just 1 times 1, which is 1. So That would be one way to do it. Another way to do it is just to now calculate the areas of the two triangles. So we have something like this. This should continue. We have this. So we have this triangle and we have this triangle. This is 1 unit. This is 1 unit. This is 1 unit. This is 1 unit. So if you use the rule for finding the area of a triangle, which is half base times height, then you have half, the base is 1, the height is 1. So half 1, 1, which is equal to half. So this area is half. This area is also half times 1 times 1. That's also half. So half plus half is 1. The third thing you could do is to find the integral, but I don't think we really want to do that. This method, which you can get by just observing, is way faster and it helps you avoid doing an integral. So that's better. All right, let's go to number 36. 36 says, how many numbers greater than 200 can be formed from the digits 1, 2, 3, 4, 5 if no digit is to be repeated in any particular number? So we want numbers that are greater than 200, and we can only use the digits 1, 2, 3, 4, 5. One strategy we can use is to say that, okay, our number can have 5 digits or 4 digits or 3 digits, or that those are the possibilities. We cannot have 2 digits because any number that has only 2 digits cannot be greater than 200. So let's start with 5 digits. So we want to know how many 5-digit numbers that we can form from 1, 2, 3, 4, 5. How many 5-digit numbers that we can form from these are greater than 200? And the answer is that any 5-digit number is greater than 200. So really the question becomes, how many 5-digit numbers can we form from these numbers? And the answer is 5 factorial. The reason is that if you want to form a 5-digit number, you can think of it this way. A 5-digit number has 5 slots for the 5 digits, 1, 2, 3, 4, 5. Now in this first slot, you have to put one of these numbers, 1, 2, 3, 4, 5. So how many choices do you have, or how many options do you have? You have 5 choices. Once you fill this, you are not allowed to repeat that number. So that reduces the number of options you have. So let's say you filled this slot with the number 4. So 4 is now out. And you have 1, 2, 3, and 5. So the next slot, you have only 4 options for that. And then for the next slot, you have 3 options. Next slot, 2 options. Next slot, 1 option. So that's 5 times 4 times 3 times 2 times 1, which is 5 factorial. Now, for 4 digits, we still have the question, how many 4-digit numbers that can be formed from 1, 2, 3, 4, 5 are greater than 200? And the answer is that any 4-digit number we form will be greater than 200. 200 has only 3 digits, so there's no way it can be greater than a number with 4 digits. So how many 4-digit numbers can we form? Again, we have 4 slots, 1, 2, 3, 4. In the first slot, we have 5 options. We can fill it with any of these 5 numbers. Once we do that though, the next slot can only have 4. The next slot can only have 2 digits. And then the next slot, 3, and then the next can only have 2. So we have 5 times 4 times 3 times 2. This is still equal to 5 factorial because multiplying by 1 doesn't change anything. So we have that for 4 digits, there are 5 factorial ways, or 5 factorial numbers that are greater than 200. We now come to 3 digits. How many 3-digit numbers that can be formed from 1, 2, 3, 4, 5 are greater than 200? Now for 3-digit numbers, we have 3 slots. The first slot, the second, and the third. Now, here in the first slot, we have to be a little careful because we cannot put 1 in the first slot. If you have a 3-digit number and the first number is 1, automatically that number is going to be less than 200. Because even if you have 1 whatever, even though we don't have 9, even if you had 199, this is the biggest number you can form, the biggest 3-digit number you can form, which begins with 1. So immediately you have a 3-digit number that begins with 1, it is going to be less than 200. So our first slot cannot have 1. However, it can have any of the remaining numbers. It can be 2, 3, 4, 5, because once you put 2, any number that comes after is going to make it greater than 200, because we only have the numbers 1, 2, 3, 4, 5 to choose from. So even if you have 1, 3, which is the smallest, it is still greater than 200. So the first slot cannot be 1, but it can be 2, 3, 4, or 5. So we have 4 options for the first slot. And once we fill the first slot, for the second slot, we just have to take out the number we put in the first slot, and we have 4 numbers left. So let's say in the first slot we put 5. Once we put 5, we have 4, 3, 2, 1 left, and any of them can fill the second slot. So we have 4 options for the second slot. And once we fill the second slot, we have 3 options for the third slot. So for 3 digits, we have 4 times 4 times 3. And 4 times 4 times 3 is equal to 48. So these are all the possibilities we can get if we want to form digits out. We want to form numbers with the digits 1, 2, 3, 4, 5. So we have to add these number of possibilities. 5 factorial is 120. 5 factorial, 120. This is 48. So 120 plus 120 plus 48. 120 plus 120 is 240 plus 48. That gives us 288. So that gives us that as our answer. Now I think this is probably the most interesting question in the exam so far, but let's see if we're going to get more interesting questions. The next question is number 37. It says, the probabilities that John and Jane will pass an examination are 0.9 and 0.7 respectively. Find the probability that at least one of them will pass the examination. Now this problem doesn't tell us that the probabilities are independent, but we have to make that assumption, otherwise we can't really solve the problem. They haven't given us enough information to solve the problem without assuming independence. So we are going to assume that they are independent, that the probability that John passes is independent of the probability that Jane passes. In that case, if we want the probability that at least one of them will pass, it's equal to the probability or the complement of the probability that no one passes. No one passes. Or the probability 1 minus the probability that both fail. So maybe I think that one is better. 1 minus the probability that both fail. So we now have to find the probability that John fails and the probability that Jane fails. Because the probability that John passes is 0.9, the probability that John fails is 0.1. And the probability that Jane fails is 0.3. So the probability that both fail is 0.1 times 0.3. Now if you write 1 minus the probability that both fail, we get 1 minus 0.03. 0.03, which is equal to 0.97. So this is the probability that at least one of them will pass the examination. Of course, we've assumed that the events are independent, but without that assumption, this problem cannot be solved, because if you want to find the probability that both fail, that probability is the probability that John fails. Let's call that John fails. Let's call that probability O, the probability that John fails. And then the probability that Jane fails, let's call that A. So if you want to find this probability in general, this probability is equal to the probability of O, that's the probability that John fails, times the probability that Jane fails given that John failed. Now, we haven't been given this number, the probability that Jane fails given the probability that John fails. So there's no way we can solve the problem. And that's why we have to assume independence. Otherwise, the problem is hopeless. All right, the next question is 38. So it's given that x and y are independent events such that p of x, the probability of x is 0.5, the probability of y is m, and the probability of x union y is 0.75. Find the value of m. Now, the probability of a union of events, there's a formula for that which you can always derive from a Venn diagram, but that probability is the probability of x plus the probability of y minus the probability of the intersection of x and y. This, if it follows directly from a Venn diagram, if you have x and you have y and they intersect, then if you want to find the union, you see that the union has to include x, has to include y. However, when you include the whole of x and the whole of y, you will have included the intersection, which is this. You will have included it twice. So you have to subtract it once so that it's not overcounted. So we just substitute these values. Now here we've been told explicitly, unlike in the other question where we were not told. Here we are told that they are independent. That means that when you have the intersection, you can just multiply. So let's go ahead. The union, this is 0.75. The probability of x is 0.5. The probability of y is m. And the probability of x and y is the product. So we have the product of 0.5 and m. So we now have this algebraic equation we have to solve, and we can go ahead and solve it. We have 0.25 equals 0.5 m. So what is m? M is now equal to 0.5. Well, that gives us that. All right, the next question is question 39. It says a uniform beam PQ is 100 centimeters long and weighs 35 Newton. It is placed on a support at a point 40 centimeters from P. So there's P here. We can call this P. And we can call this Q. All right. If weights of 54 Newton and F are attached at P and Q respectively, so we have at P, we put a weight of 54 N, and at Q, we put a weight of F Newton. And this is done to keep it in horizontal position. Calculate correct to the nearest whole number the value of f. Now remember, we've been told that the balance point, or if you like the pivot, is at this point that is 40 centimeters from P. So this distance is 40 cm. And what other information do we have? We've been told that the weight of the beam is 35 Newton. Now, because the beam is uniform, we're going to assume that its weight acts from the center of gravity, which is precisely in the middle. So at some point here, the weight of the beam is going to act, and this is 35 Newton. That point is precisely the point that is 10 centimeters, because the beam is 100 centimeters long and its center of gravity is going to be at the 50 centimeter mark. So this is another trick you need to know, that when you have a beam that is not weightless, it's a beam that has a weight, then its weight, if it's a uniform beam, its weight is going to act from its center of gravity, which is going to be in the middle. So this is the setup we have, and we have to balance the moments. We have to find the sum of clockwise moments and then set it equal to the sum of anti-clockwise or counterclockwise moments. So the clockwise moments, actually let's start with the counterclockwise moments, the ones on the left. So there we have 54 times 40. I'm going to ignore units. So 54 times 40 equals the moments on the right. There we have 10 times 35, 10 times 35 plus f times 60. The distance from this fulcrum or pivot point to this is 60 centimeters, because the other side is 40. So we have 60 times f, which is 60f. And now we have to find f. Well, we can write 54 times 40. What is that equal to? Well, 4 times 4 is 16. We have 1. 4 times 5 is 20. So 2160 equals, let me just, because we can bring this 10 times 35 to the other side, so we can write minus 350 equals 60f. So we now can find f. F equals this 2160 minus 350, and then you divide the result. So let me write it. 2160 minus 350 over 60. Now what is this equal to? We can punch this into our calculator to get the result, but if you're feeling adventurous, we can do it by hand. The reason we are not scared to do that is that we can see that 216 is a multiple of 6. So ignoring the zeros, we divide 216 by 6, and what do we get? We get 36. So we get 36, and then we have minus 35 over 6. So minus 35 over 6. Now 35 over 6 is equal to 35 over 6 equals 5/5/6. So if we now have 36 minus 5/5/6, what does that give us? It gives us 31/6. So that's our final answer, 31/6. And it says we should find it to the nearest whole number. So the nearest whole number to 31/6 is 30. So that's our result. But again, like I said, you can punch this into your calculator and just get the answer and not worry about it. The next, which is our last question, is evaluate this limit. The limit as x goes to 1 of 1 minus x over x squared minus 3x plus 2. We can try to factorize this quadratic. When we do that, we get x minus 1 times x minus 2. Now, x minus 1 is the same as negative 1 minus x. So that's the trick. Let me write it more nicely. X minus 1 is equal to negative 1 minus x. So what that means is that we can cancel this x minus 1. We can cancel this and this to get minus 1 here. So this becomes the limit as x goes to 1 of minus 1 over x minus 2. Now, if we just substitute x equals 1 into this, it's going to be okay. So we go ahead and do that. 1 minus 2. This is minus 1 over minus 1, which is just 1. So that's our answer. Now, I should have said, we could have begun by saying, let's put x equals 1 into both of them. We put x equals 1 into the numerator and the denominator. But if you do that, you will see that you get 0 over 0, which is an indeterminate form. So I skipped that step, but if you do that, you'll see that you get 0 over 0. So you cannot really proceed. So you have to factorize and then simplify, cancel out some things, and then get a final result. So we've come to the end of our series of videos where we solve the questions in the WASSCE 2019 May-June Elective Math Paper 1. It's been an enjoyable journey. Let me know what you think of the questions, of the answers we gave. If you have any suggestions, if I skipped some steps that you would like clarification on, you can let me know in the comments. And I plan to do more of these videos, so hope to see you in the next one. Bye.